Chapter 14, Programming and Data Representation. Learning objectives. By the end of this chapter, you should be able to program in a high-level language using Python. There are two other languages, Visual Basic, Java allowed, but we will be doing Python. Implement and write pseudocode from a given design, presented as either a program, flowchart, or structured English. So algorithm, as you know, algorithm can be either pseudocode, flowchart, or structured English. Write pseudocode and program statements for the declaration of variables and constants. The assignment of values to variables and constants. Where declaration of variables and constants, that is how you declare what type of data is this variable going to use, or the data type of that variable. The assignment of values, that is giving the values to various variables. Expressions involving any of the arithmetic or logical operator, using arithmetic operators and logical operators, how to prepare expressions. Input from the keyboard and output to the console. How to input data and then output to the screen. Use a subset of the built-in functions and library routines supported by the chosen programming language, including those used for string, character manipulation, and random number generator. All languages provide their libraries with built-in functions, which the user can use in their programs. If I make a program, I can make use of these built-in functions in my user program, and including random number generator, how to generate a random number for games and all that. Use an if structure, including the else clause and nested if statements. Use a case structure, that is also another way of checking the conditions, like if then else is also another structure where you can select a path. Use a loop, that is repetition, either count control, post condition, or precondition. 3 types. We'll learn that also. Justify why one loop structure may be better suited to a problem than the others. Justify. You must prove or explain why you use either this, that, or the other. What is the advantage? Define and use a procedure and explain where in the construction of an algorithm it is appropriate to use a procedure. And also how to use parameters, passing parameters to procedures and all that. So understanding of passing parameters by reference and by value. 2 ways of passing parameters. One is by reference, the other one is by value. Define and use a function and explain where in the construction of an algorithm it is appropriate to use a function. So you can define, you should be able to define and also explain where it is suitable to use. So understanding that a function is used in an expression, the return value replaces the call. Like a equals and a function name with a parameter, that a will get the return value from a function. You know the difference between function and procedure. Function returns a value, whereas procedure doesn't return a value. It just does the task and exits. Use terminology associated with procedures and functions. Terminology for procedures and functions. Procedure, function header, procedure header or function header, procedure or function interface, then parameter, argument, return value. Those are the terms. Right? Finally, write efficient code. Okay. let's talk about programming languages. Chapters 12 and 13 introduce the concept of solving a problem and representing a solution using a flowchart or pseudocode. We expressed our solutions using the basic construct, that is assignment, sequence, selection, iteration, input and output. So now, as I mentioned these words, you must get the picture of the construct. But assignment, like A equals 10, sequence, that is in order. You can't say where the shoes and then where the socks. It's out of sequence. You have to give it in the correct order. Selection. If you are hungry, eat, else drink. Like that. Selection. You select a path to proceed depending on a condition. Iteration needs to repeat input and output. So these you must always get to your head if then else. When you say selection, if then else. Then as I say iteration, for loop or a while loop or repeat until must get. And input and output, of course, very familiar with it. So no need to worry about that. To write a computer program, we need to know the syntax. What is syntax? The correct structure of statements. Each language has its own syntax. Of these basic constructs in our chosen programming language, this chapter introduces syntax for Python, Visual Basic Console mode, and Java. Note that for convenience and easy reference, definitive pseudocode syntax is repeated in this chapter at the appropriate points. You only need learn to program in one of the three languages covered in this book. So we are learning Python. Tip. The only way of knowing whether the algorithm you have designed is a suitable solution to the problem you are trying to solve is to implement your pseudocode in your chosen programming language and test the program by running it. Because on paper, if you write pseudocode, there is no reaction or response from the paper, and you will not know whether your solution is correct or not. So here's a little bit of history about Python. Python was conceived by Guido van Rossum in the late 1980s. Python 2 was released in 2000 and Python 3 in 2008. Python is a multi-paradigm programming language. Multi-paradigm programming language. Paradigm is like a style of programming. Meaning that it fully supports both object-oriented programming and structured programming. So the paradigms are object-oriented programming, structured programming. There are some more like declarative. So those things, this generally one language supports only one, but this one supports two, which are these. Many of other paradigms, including logic programming, are supported using extensions. These paradigms are covered in chapters 26, so that's a long way to go. In these chapters, we will be doing in detail. The Python programs in this book have been prepared using Python 3 and Python's Integrated Development Environment, IDLE. Integrated Development Environment. The L is taken from this. The capital L here is that development. So the D and L for one word, development. Key characteristics of Python include the following. Every statement must be on a separate line. Indentation is significant. This is known as the offside rule. What is indentation? Indentation. Let's take a look at what indentation is. It's very important in Python programs. And we can have a look at the program, Python program also. And then I will tell you what indentation is. Even in pseudocode, you have to if A is greater than 10, then see that is indentation going away from the margin. Then um, output is ended. This is indented. The highlighted one is away from the margin. Arrows also shown. That is the meaning of indentation. In Python, let's see. This is the idle. I'll take a program file, your program. A equals 10. If A is greater than 10, of course, you don't put then, here you put a colon and then when I press enter, it automatically is indented. The cursor goes there, I press enter after a colon. So that is to help the programmer. You don't have to indent. In case you are here, you end up here without pressing enter, if you put the arrow, then you have to indent by pressing the tab key. There's a key called tab, left side above caps lock on the keyboard. If you press that, it will come. Then say print. Output in Python is Okay, so that was the value was different. That's why it didn't come as 10. Now I made it 20. If A is greater than 10, 20. Then if I save and run it, it's 20. Huh? So that is how it works. And if you make it less than 10 or change this to less than 10, then it will not print anything because it's not correct. So if or else and I out this and say else, then that has to be unindented. Else has to go back to the margin. A colon is necessary and then print, print, print less than and if I put A, sorry, less than 10, less than 10. A, B, less than 10. More than 10, it will print the value of A, 20, 30, anything. But if it is less, it will say that much, whatever the number input is less than 10. We are checking for 10. But what I'm trying to tell you now is the indentation. See, this is what you call the indentation. It gives 20. Now I'll change this to less than 10. 8. And run it. And it says 8 is less than 10. Now, indentation is significant. If you, it will not work, otherwise it will not work. If I expected an indentation block after if statement on line. So that's it. Going back here. This is known as the offside rule. Offside. From the margin, you have to go off. Like off-road. Keywords are written in lower case. You may have noticed this. If, else, these are lowercase or simple. Python is case sensitive. The identifier number 1 is seen as different from number 1 with simple N or all capitals number 1. Let's try that one. Now I put simple A and I say capital A here. All right, now here's another lesson on logic. This, if A is greater than 10, if this condition is true, this will happen. This will not happen. But if this doesn't happen, if this is false, like, I mean, in this case, it's false, no? 8, first you must translate this. 8 is greater than 10. Then you must check whether it's true or not. 8 is greater than 10. That's a statement. You evaluate it. Is it true or not? No, it's not true. Then you have to do this. Then here I'm using A. So there will not be an error. Only if I make this more than 10, this part will take place and then the error will come. So that also we can try out with this. This time, there is no error. 8 is less than 10. Now if I make this 20, then only. So that means this has not happened. Now it will happen and the error will appear. There you go. name A is not defined, did you mean simple A? So that shows clearly how only one of them will happen. Both will not happen at the same time. Names or the identifier names. Another term is identifier for variables because you identify the data, that data structure with a name. So let's say identifier. With that name only you identify. Identifiers have to be the exact spelling as you have declared. Everything in Python is an object. See chapter 27, that is object-oriented programming. Will come in chapter 27. Everything in Python is an object. So you create objects and then they have methods and attributes. So that will come later. But remember, code makes extensive use of a concept called slicing. Slicing. So in this same chapter, we'll be doing that, taking slices of a string. Programs are interpreted in chapter 8. We have already done section 8.05 for information on interpreted and compiled programs. You can type a statement into the Python shell and the Python interpreter will run it immediately. So these are the ones that we have seen, and immediately is here. You want right, A equals 50. Print A. It will give the result here. Whereas in this, if I type something and press enter, nothing happens. This is a place where you type your statements or instructions. Then you run it. Here, you immediately will get the results, but you can't save anything. You can't have these instructions saved anywhere. That's immediate mode. So that's a lot of things about Python. Example, running a statement in the Python shell. Even this we can try. Print hello world. Usually, first program, any program address is to output this. And here it came hello world. You can also type program code into a Python editor, such as idle, save it with a .py extension, and then run the program code from the run menu in the editor window. See figure 14.02. A save program in the Python editor window and running in the what I did earlier to show you the indentation. So you can, let's try a normal editor, whether we can do it. Start a notepad and copy this. Yeah, copy this notepad, save it as the extension should be dot py. So text editor dot py, like saving HTML files. Save. Then open it. I'll run. Yeah, this is chapter 14. So I'll run this and get the idle. Okay. Now close this other file. And from the idle, you can open that file. You save it on the desktop called the text editor. And here it comes, same way. And then run it. Yeah, it's the same. So let's try again. See whether this is, will change the figures, right? Oh, then save it. On the ID, text editor. Yeah, it doesn't run like that. You have, it always opens here, text editor. Then only run it. Then says 4 is less than. That is how this program. Save program in the Python editor window. That is this one. My first program and print hello world. Be running in the Python shell. It will appear like this. Visual Basic, no need. Java, no need. 14.02, Programming Basics. Declaration of variables. Most programming languages require you to declare the type of data to be stored in a variable. So the correct amount of memory space can be reserved by the compiler. A variable declared to store a whole number, which is called integer, cannot then be used to store alphanumeric characters, strings, or the other way around. VB.NET and Java require variables to be declared before they are used. Python handles variables differently to most programming languages. It tags values. This is why Python does not have variable declarations. Oh, there's a small difference in also before starting, we have to declare like this, declare. A colon as integer. Integer also pseudocode. So this is pseudocode. Huh? Declare A as integer, and then you can't input so in a Python, you don't have to do it. Or here also, A was just used. When it says A equals 4, it automatically, Python, it automatically takes it as, um, as what do you call an integer. An integer. Right? Takes it as an integer. So the difference, there's a big difference here in Python. No declaration of variable, no data types. Tip. It is good programming practice to include a comment about the variables you are planning to use and the type of data you will store in them. This is for Python. In pseudocode, variable declaration is written as declare, identifier, and data type. So, uh, since you don't have it, in Python, we don't declare. Comment. A beginning also you can have hash symbol, a hash symbol. This is a comment. So this will be ignored by the processor. By the program, it will be ignored. This is for the humans, not for the machine. It's a comment. So here you can have a comment. Say that age, let's say if it is an age, so I'm putting age or something like that. So one say n equals something name. Likewise, these are the, then here also you can say if it is greater. If this happens, that means A is greater than 10. And here you can have a comment A is less than 10. Here, of course, we are giving a description also. For example, you may declare the following variables. So here the word declare is essential for pseudocode and identifies the name of the variable A, B, or name, age, gender, those things, the variable name identified. And the colon is essential, the data type. What is the data type you are using? Then declare number 1 as integer. This declares number 1 to store a whole number. Declare your name as string. This declares your name to store a sequence of characters. Declare n1, n2, n3, colon, integer. So this way also you can do in pseudocode. Declares 3 integer variables. Declare name1, name2, comma, with the comma. You have to separate them with the comma. String. Declare 2 string variables. Syntax definition. The syntax of variable declarations in language code is as follows. In Python, Python does not have variable declarations. In the code example, number 1 of type integer. These are the comments. Your name of type string. N1, N2, N3 integer. Name1, N2 string. There are no declarations, but comments should be made at the beginning of a module. See the section about comments at the end of section 14.02. Very soon you will see that. But will the program run if you don't give these comments? Program will run, but the examiner will not give you marks. Or another example, real world example is you do a Python program and you leave the company. You leave the company as a programmer, another programmer comes and he will not know what it is, what are the variables used and for what purpose, if you are not given the comments like this. Otherwise, the program will work without them. Declaration and assignment of constants. Sometimes we use a value in a solution that never changes. For example, the value of the mathematical constant pi. So variable is something that varies, some changes, but constant is something that doesn't change. Instead of using the actual value in program statements, it is good practice and helps readability if you give a constant value, a name, and declare it at the beginning of the program. Let's see the meaning of it. Right? Constants. See how constants will be used. I say E equals 10. Only that D is enough. If what? Discount rate. So you can't put 10% there. You put 10. That means 10%. Amount. Input the amount. How you are learning, you are going to learn something, how to input. Amount. Bill amount. Usually you use the first letter. Amount equals integer. Input amount. Legend discount. Sorry. D equals amount multiplied by 10 and divided by const. When you're saving from the Python idle, you don't need to um, give the extension .py. If you are just using any other normal notepad or something, then only let you give the .py. Enter amount, say 100. Count is 10. Run it again and give a different amount. Say enter amount 200. 20. So that's correct, no? But supposing this statement is used several places, about 10 places. And in the program, you can have several places using this enter amount 300 and 30, 30, 30. You get all four places. Now you want to change the now actually this was not there. Imagine that this is not there. Still it will work. Still it will work. Enter amount 400. Yeah. Why is that? But we are not making use of D here. Just for demonstration and now you want to change this amount to the rate to 15%. What do we have to do? We have to go and change everywhere. If it is 10 places, all 10 places we have to change and This is not so straightforward in the program. They will get long statements, short sentence statements, and many statements. You might even miss one like this. So don't change it. What happens then? 100. Yeah? It changes, which is, and the last one is faulty also. Why don't we, instead of doing everywhere, why don't we use a variable called d here? We have this constant value. So, so that's why I say, don't say variable, it's an identifier. Then we have to make use of this. D equals 20%. Then run. The amount, 100. Want to make it 30? Just change only that. 200. Drive. Oh, what is that? D 30. Oh, yeah, in that case, there is a problem here. D equals amount into D. It's the same, we have to change this. Discount and then print discount. No, equals amount. Yeah, yeah, correct. You have to change. Otherwise, the D changes. So with every statement, the D changes. So you have to be careful. It will remain the rate. We should not change the D. Early it was okay because it was not using this variable D. 100, 30%. We change it to 40%. Just change this and then run. 100. Constant. So the one advantage of declaring constants. Otherwise, you need not. No? You did not declare constants because as earlier, you could have used 30 divided by 100 or whatever. But that won't do. In the long run, it won't help. But if we give a constant value a name and declare it at the beginning of the program, it's a good practice, it says. So this is the way. In pseudocode, constant declarations are written as constant is the word like declare. Constant is a word to declare the constant, and then the identifier, the name equals value. It actually it's not declaring like giving a value also, like initializing both at the same time, right? For example, constant pi equals 3.14, right? In pseudocode, remember. So in Python is the identifier value, which is a equals value is 10. All right, that's what we did. D equals 10, 20, 30, that's about. And code example pi equals 3.14. Python convention is to write constant identifiers using uppercase only. Python convention. The values can be changed, although you should treat constants as not changeable. So uppercase only. So that is in um, like P I, capital P, capital I. All right, that is the idea. Then if we use capital A, a simple B, C, then we know it's a variable because all are not capitals. If all are capitals, A, B, C, A, capital B, capital C as a variable or identifier will indicate that it's a constant. Not to the program, remember again, it's not to the program, to the programmer. Then assignment of variables. Once we have declared a variable, we can assign a value to it. In pseudocode, assignment statements are written as they identify a name, the arrow assignment sign, and the expression. Either it's 34 or B plus 1 is an expression. For example, A equals 34, B equals B plus 1. Those are expressions. Then syntax definition and code example. Identifier equals expression. So A equals 34, B equals B plus 1, the assignment operator is equal sign. Then we come to arithmetic operators. Assignments don't just give initial values to variables. We also use an assignment when we need to store the result of a calculation also. Not only initial values, but in the process of executing the program, there are other places where results have to be stored. The arithmetic operators used for calculations are shown in table 14.01. So these are the arithmetic calculations. This Python. Addition is plus, subtraction minus, multiplication asterisk. That's different from the normal written arithmetic. In writing, we use a X sign for multiplication. Division, the slash here. Exponent. Exponent is asterisk, asterisk, double asterisk. Multiplication is 1 asterisk. Exponent is 2 asterisks. You have to remember this. An integer division 11 and modulus division this percentage sign. There are 3 kinds of divisions. There are 3 kinds of division. About the examples are like VAT. The government imposes a VAT, a tax, value-added tax. So the governments come and change them. So when you change in the program, if there are about 20 places where VAT is, the rate is used, then it's only a case of changing only at the beginning. That is the idea. Still, we are in 14.02. Operators. You know all the others. This I'm trying to give you like the division methods. 10 divided by 3. What's the answer? That will be 3.33 something or that. You get it's a real. It's called real with the decimal places. So also it's called real division. Real division. You get it, but the 10 divided by is a little bit misleading. We'll take it as a 4. 0.5, no? 0.5. Here, if it is 4 plus 2 only, that means integer. 10, actually, this is not, yeah. Let's see the operators given. This double. Integer division is double. And this is pseudocode I gave. So in Python, double, double slash. Here it's the same. Division is okay. And here the mod operator is integer. Integer 4. That's also coincidence. This gives a remainder. So here is 2. If we change, now let's learn what it is. Modulo. The remainder. We take something different. 12 divided by maybe 15. 15 divided by 4 is how much? 3.75. No? 3/4 0.75. Then here 10 divided by 4. The whole number is, sorry, 15. We have to change this to 15. And whole number divided is 3. The 0.75 will not come. And modulo 4. This will be how much? 1. 4 times, sorry, 3. They also coming 3. 15 divided by 4 is 3 times 4 is 12 and remainder is 3. Right? So don't mix this up with other things. So if you want, you can do another, like only for this we can change this. 18 modulo 4. Mod 4. How much? 4 times 4 is 16 and is 2. Another one. 10 modulo 5. 10 mod 5 is 5 times 2 is 10 and there is no remainder. So 0 is the answer. So remember these things. Mod in Python, mod is this percentage and integer division is this. So let's have a look at that also in the shell. 20 divided by 3. Okay? That is the real division. Normal 1 slash. 20 slash 3 be only the whole number part of the answer, 6. And if you put 20 percentage sign and 3, be 2. Because 3 times 6 is 18 and the remainder is 2. Then what are we going to do? Tip. The result of integer division is the whole number part of the division. For example, 7 div 2 gives 3. Div 2 is the pseudocode, remember? And in Python, it will be 2 slashes. Sorry, I forgot this. That will be double slash there. Integer division. Okay. Oh, it's div. That's in Python. 15 div, the pseudocode. Pseudocode. This is no change in Python in pseudocode, but in pseudocode 15 div 4. Yeah. Then the mod. This also I will change to the it's a remainder Python mod, and this, I'm sorry, yeah, this is also then mod. It's very clear now. 7 mod 2 gives 1, right? 2 times 3 is 6 and remainder is 1. When more than one operator appears in an expression, the order of evaluation depends on the mathematical rules of precedence. Parentheses, exponentiation, multiplication, division, addition, subtract, like that. BODMAS, the order of rules of precedence. So here is a good exercise for you to do. Rules of precedence define the order of, this will define the order of the calculation to be performed. So evaluate each of the following expressions. This one. Let's try it here. You have to try all these things. Remember, in Python, you have to try each and every thing. No brackets, no brackets in there. Going to 3 minus 3. This sign we have to change. I wonder whether you remember how to make it exponent to the power double S. Syntax is invalid on this. Sometimes when you copy and paste, you have to delete and change. And also take the cursor there and press enter. It will be duplicated here. You don't have to type the whole thing again. Delete and type the -1, then it comes. So 3 is the answer in that case. Next one. Brackets are used. Change this to the power and this minus sign. It gives 81. You see, the numbers are the same, no? All 3, all 4 4 into 3, 4 into 3, 4 into coming. Minus is the afterwards, then afterwards to the power 2. But the way the brackets are placed, the results will be different. Now let's take the third one also and see. Pasted, change to the power, change the minus sign, then 0. Why is that? Okay, let's take one by one in case you missed it. Here, 4 into 3 is what happens? This is the precedence. 3 to the power 2 is 9. Okay, 3 to the power 3 to the power 2 is 9. 3 into 3 is 9. Then 4 into 3. 4 into 3 is 12. The next in line order of precedence. Then finally the minus 1. So 9 minus, sorry, 12. This is 12. 12 minus 9 is 3. And the next one, the brackets come. So because of the brackets, inside the brackets also, this is 12. 12 minus 3 is 9. Inside the brackets, 4 into 3 takes precedence, priority. 4 into 3 is 12. 12 minus 3 is 9. And then 9 to the power 2 is 81. Here the brackets are here inside. So 3 minus 3 is 0. First of all, it becomes 0. So any other multiplication or any exponentiation will give you 0. Then the fourth one. Bring to the power and the minus sign. The center, it's minus 20. Out. Inside the brackets, 3 to the power 2 is 9. So 3 minus positive 9 is minus 6. 3 minus 3 minus 9. Here is 9 is 6 minus 6. Minus 6 into 4 is minus 24. Reminding again, you have to do these things, each and everything. Otherwise, you will find it difficult. Outputting information to the screen. In pseudocode, output statements are written as output and the string or output identifiers. String will be a constant or the identifier will be either string or whatever. When outputting text and data to the console screen, we can list a mixture of output strings and variable values in the print list. So you can mix up constants and variables. Python, print list. There can be many things. Print list items are separated by commas. We have to, like a list, normal list, we have to put a comma to separate. This is what, to avoid moving on to the next line after the output, use end equals a blank here. Print list, comma, and this part is additional. Shall we try that? List. Name. And paste it out straight away. the idle, and then it prints 10, 20, 30, name, 100. But if you are using a list or list in Python, you can learn it now itself. Later on, we'll get it. Of course, that we have to give in brackets, brackets, and 20, 30, 40. So we are printing in order with a loop, the loop, right? For the loop, we can use, there is no repeat until in Python, early so that you will learn these things early. For n in range, you will get familiar with these terms. For n in range, colon, don't forget the colon, and when you enter and print, um, with list, index, n. First one, means one. First one, in Python is 0. 0, 1, 2, 3, and fourth one will not be done because Python stops one before this number. Those things, again, don't worry. At the moment, what I'm trying to do is print one by one. New line. In list is not defined, but it's there. Print. You have to put in brackets. All right. Syntax error. Those are the ones that are called syntax error. Now this goes on to new line. But in case you want to print it on the same line, you have to put a comma after the items, the item, comma, and end. End equals simply nd equals a space. Then run it. There you go. It comes on horizontal line. And this space is the one that comes in between. If I just put a empty string, is called empty string, then what happens? It will be like one number, because there is no space here. If I put a dash, what happens? The dash will come in between. Yes. Example of how the end equals thing and also printing list. The examples below, the print list consists of 4 separate items, hello and your number are strings, and your name and number 1 are variables for which we print the value. In pseudocode, we can indicate whether a new line should be output at the end by a comment at the end of the statement. So here, a new line. At the end, you put a new line. That means to go to the next line. Or you can, if not, you can say remain on the same line. Output hello, your name. So this is an identifier. Hello is a constant. This will have to input or whatever. Then your number is also within inverted commas. Within inverted commas, it's a constant. And number 1 is an identifier. Then hello, no new line. When you say no new line, that means on the same. But this won't have any effect because anyway, this has gone to the new line already. What is coming after this only will be on the same line. So print hello, your name, your number is. I can copy this, but will I to define the variables or initialize the variables. If I just do this, yeah, let's run this. See, you say your name and all those things are not defined. See, not defined. So if this is not in inverted commas, then it looks for a value in it. The moment it sees the inverted commas, no problem. Even if I make a mistake here, even it will simply print like that. Hello with one single L. And this, it will look for a value. So let's give a value. Name equals Tom. The other required variable or identify this number one equals 1, 2, 3, 4. Now let's run it and see. Okay. Hello, Tom. Your number is 1, 2, 3, 4. And hello. New line. Hello. This hello is an a constant. Hello is in within inverted commas. Your name. You can run it again and give some. No, we have to change this and see. And then your number. And this won't have any n equals single. But it doesn't have any effect because we already passed this part. Now if I change this to Harry and run it, we'll see the difference. And also this one. 2, 3, 4, 5. Hello, Harry. So the name changed. The number is 2, 3, 4, 5. Number is also changed. In the code examples above, you can see how output statements can be spread over more than one line when they are very long. But you must break the line between two print list items. You cannot break in the middle of a string unless you make the string into two separate strings. So let's look at this. How we can break into two lines. This will work. Yeah, but if I break it here, what will happen? Unterminated string literal detected at line 3. So line, they count 1. So this is taken as the literal and not completed, not terminated. So because of that, you can't break outside to start in this, either here or here. This also will work. The closing bracket is on the next line. Yeah, that also works. In Python and VB.NET, you can use the placeholder method for output. The variables to be printed are represented by sequential numbers in these curly braces. They are called curly braces in the message string, and the variables are listed in the correct order after the string separated by commas. So this hello, 0. Your number is 1, format your name. And comma, number 1. I'll run this and then explain. Dashes, just to program and but we are using the same variable names of this. That's why I'll have to, if I'm doing another program, then we'll have to, but I'm using these same variables. Invalid syntax, what is that? This is a string. String has to be within inverted commas. Yeah. Hello, Harry, your number is 235. That is the normal way, no? But here, hello, Harry, your number is 2345. Now I'm going to change something and see. I'm going to change this to 1 and the next one is 0. 1 and this is 0. That's like an order sequence. 0. Now see what happens. Hello, 2345, your number is Harry. What happened? Because these your name and number 1 is there, right? Your name is 0, number 1 is 1 in this, within this bracket. The order is, this is 0, this is 1. So if you use 1 here, the number will come. And if you use 0 here, the name will come, your name. But earlier it was, this is 0 and this is 1. Then 0 is your name and number is, that is the way this is used. Within curly braces, remember. It's like formatting. It's called formatting. So getting input, how do you get the inputs from the user? When coding an input statement, it is good practice to prompt the user as to what they are meant to enter. For example, this pseudocode statement input, enter a number and A. This way is also written. There are certain variations of pseudocode. Usually you put output, enter a number, and then the next line input A. Here both in one. Note the space between the colon and the closing quote. This one, colon and the space. This is significant. It gives a space before the user types their input. Yeah, this one, I have put a colon here and so let's run it again and see. It's nicely placed. No? There's a space and all that. I remove that if I didn't put, in other words, no space, no colon, then run it. Now see, I put 100. It's like not nice like this. No, see, this is nicely placed here, nice format. But here, all jam like program works. Program will work, but it's not nice. So A equals in, yeah, A equals input, enter a number, colon, and a space. That is what I. The prompt is provided as a parameter to the input function. So you are early learning. You are learning this parameter, which will come later in the chapter. This is passed to this function. This is a built-in function input or procedure. So when we pass this one, this will go and print it on the screen. Passing parameters. Comments. It is good programming practice. We did that. This is a comment. This is another comment. That is good. Then task for you to do. Use the ID of your chosen programming language, that is Python. Type the program statements equivalent to the following pseudocode. You may need to declare the variable your name first. Yes, you saw no earlier. So input what is your name, and your name is the variable to have to store. The user will input a name that will be stored in this. This is pseudocode. Then output, have a nice day, your name. That is two combined. This is a constant, have a nice day, and this is a variable, whatever the name that is input by the user. Can vary, that's why it's a variable. Save a program as example 1 and then run it. Is the output as you expected. Next time it will be 14.03 data types. Till then, see you. Bye.